Welcome to Maths for All. I'm Aisling Flynn. This is Number Patterns 1.2, Arithmetic Sequences. Sequences. Write down the next 4 terms in the following sequences. So this is often something students can do automatically. So have a look. Pause the video and write down the next 4 terms. Did you get 11, 13, 15, 17? Okay, so you look and you see what's happening with the numbers 3 to 5 to 7 to 9. They are increasing or going up by 2 each time. Okay, and you continue that pattern or sequence. In the second sequence, I got 24, 28, 32, 36. So I looked at the numbers from 4 to 8, 8 to 12, 12 to 16, 16 to 20, and it appears they are increasing or going up by 4 every time. And looking at the third one, did you get 12, 10, 8, 6? So in this one, the numbers are falling or decreasing from 20 to 18. It goes down by 2, down 2 to 16, down 2 to 14. So we continue this pattern on. Okay, so arithmetic sequences. So the previous slide were all arithmetic sequences. Okay, in an arithmetic sequence, the change between one term and the next is always the same. So if the numbers are falling by 2, they will continue to fall by 2 each time. This is called a common difference, or D. The numbers rise or fall an equal amount with every term. And if this is drawn on a graph, it looks like a straight line. For this reason, arithmetic sequences are also called linear sequences. So here's a graph, and the blue dots appear to show a straight line. Okay, and the graph above shows the sequence 10, 15, 20, 25, 30, 35, and so on. So it is linear. The common difference from term to term is 5, and it is always the same. So it forms a straight line when you put it on the graph. Linear sequences. So a question may ask you to explain why each of these sequences is linear. So what you do is you investigate the difference between the terms. Okay, so pause the video, take a piece of paper and find the difference between term to term. Okay, so let's go back a little bit. The top one, 3 to 8 is 5, and 8 to 13 is 5, and so on. So the common difference for the first sequence there is 5. Okay, let's look at the second one. The numbers are falling. Are they falling by the same amount every time? It has to be the same to get a straight line on the graph. So 18 down 4 to 14, down 4 to 10, down 4 to 6. So yes, they're all the same change each time. And what about the last one? Minus 2 goes to minus 4. So it's going down to further down into the negative numbers. Minus 4 goes down 2 to minus 6, and minus 6 goes down 2 to minus 8. So yes, they are all linear because the difference from term to term is constant. If the differences were changing, then the conclusion is they are not linear. Now, describing arithmetic sequences. To describe a sequence, 2 pieces of information are needed. The first one is the first term, which is A, or we saw previously, it could be called T1 also, okay? And the common difference, so the change from term to term, D, you need to know that. So here's an example. The first term of a sequence is 4, so that's A, And the term-to-term rule is add 4, so that's D. And the question wants you to find the second term of the sequence and the fifth term of the sequence. So first we're going to write out our sequence. So starting with 4, we must add 4 each time. So that goes 4, 8, plus 4 is 12, plus 4 is 16, 20. Okay, so we have 5 numbers there. So we can say that the second term, T2, equals 8, and the fifth term, T5, equals 20. So describing arithmetic sequences. For each of the following sequences, I want you to state the values of A and D and write the next term in the sequence. So here's 3 for you. Pause the video now, take a piece of paper and find A, D and the next term. Okay, for the first sequence, did you get A equals 1, D equals 0.5, so it's only going up by a half each time, and the next term then would be 3, going you plus 0.5 each time to the previous term. For the second one, did you get A equals minus 10 and D is equal to plus 2, or just 2, all right? So minus 10 is going up, so you're going up towards 0, and minus 10 goes up to minus 8, which goes up to minus 6, which goes up to minus 4, and so the next term will be up to minus 2. So getting closer to 0, and then the pattern will cross over 0 and go into the positive numbers. Okay, and what about the next one? A equals 6 and D equals minus 3, because the numbers are going down. So 6 minus 3 is 3, 3 minus 3 is 0. So the next one will cross over into the negative numbers, go below 0. 0 minus 3 is minus 3. Okay. Now here's a problem solving question. Okay, we'll go through this together. So x, 2x plus 1 and 5x minus 4 are the first 3 terms of an arithmetic sequence. Okay, find the value of x and the fourth term of the sequence. Okay, so it looks a little different. We don't know the numbers of the pattern, and we've got this unknown number x. Right, so problem solving, you ask yourself, what do I know? Well, what do we know? We do know, because we are told in the question, that it's an arithmetic sequence. And what do we know about arithmetic sequences? Well, we know that the common difference should be constant. Okay, so that's what we know. How will we use it now? So what do we need is the next question. Well, we need to solve for x. So if you're solving for x, you need an equation. You want to finish with x equals. So it is up to us in this situation to make an equation. And to make an equation, you put 2 things equal to each other. So you have left equals right. Now what can we do? What can we make equal to each other given what we know? So this is what we're going to do. If we take terms in the sequence side by side, and if we subtract them, we should get the common difference. So you should get the same difference if you take the third term, take away the second one, should give you D, and it should be the same as if you take the second term minus the first term. So they both should give you D equals D. So this is how we form an equation, how we make an equation. So, and the next job here is to substitute in for T3, the third term was 5x minus 4. We have to take away the second one, 2x plus 1, equals T2, 2x plus 1 minus x, which was the first term. Okay, so do you see the logic there? Pause the video and review if you need to. Now, what do we do next? Well, we have to solve. We have an equation now, we have x, and now we can solve. So this is brought over from the previous slide. So notice I use brackets around each of the terms. You'll see why so in the next line. So they don't really have a function at the beginning with the 5x minus 4, but when you take away t2, you have to take away 2x, but also you must take away the 1. So you apply that minus 2 times to each term. Okay, equals 2x plus 1 minus x. Simplify, so on the left you have 5 take 2, you have 3x minus 5, and on the right you have 2 take 1, you have 1x plus 1. Okay, now x is on one side, numbers on the other. We have this, simplify, I get 2x equals 6, and divide both sides by 2, you get x equals 3. So we have solved for x. Okay, now you may think you're finished, but let's go back and read the question and answer the question we are asked. Find the value of x. We've done that, but we also have to find the fourth term of the sequence. Okay, so to do that, we're going to use what we know as x now to make our pattern, our sequence. So if the first term is 3, the second term is 2 3's plus 1, which will be 7, and the third term is 5 3's take 4, which is 11. So that's our pattern. You can see that the common difference is 4. So the next term, the fourth term in the sequence, should be 15. Okay, well done. You'd try some now, do your quiz and written exercises. Here's a short glossary.